And we are live.
In 2018, a crack YouTube unit was sent to social media prison by an algorithm for the crime they didn't commit. These producers promptly escaped from maximum security social media stockade to the internet underground. Today, still wanted by social media, they survive as producers of fortune. If you have a problem, if no one else can help, and if you can find it, maybe you can hire the Smash team.
All right, thanks for joining us, whoever might be here, because I can't see the chat yet. Looking at the sun and 171 angstroms. We see sunspot 2734 about to set as an active plage region rises. And where's my epic pen? And we see some activity. All right, let me draw. All right, there we go. We see some activity in this region also. And let's look at some different views. Here are the magnetic lines at 193. So we see this large coronal hole facing right at the Earth right now. And that's what's raising your earthquake risk, folks. Yeah, we finally have had a 6 magnitude earthquake. We will cover it. Also, I would note the magnetic complexity associated with this rising plage, which is why the it's playing a little bit of havoc with the magnetic fields. Nothing too major, but we will cover it momentarily. All right, so let's look at the real-time solar wind here. So we see some wild shifts here in the BTBZ very recently, actually. And now we're seeing a possible connection starting to form right here with that coronal hole. Remember, folks, new viewers, when you see this phi angle riding around 180 degrees, like it is here, and through here, that raises your earthquake risk. Also, an extreme negative BZ like this, that's also an earthquake risk factor. Anyway, we had a pretty high solar wind density there for the past 24 hours. And as the coronal hole wind stream arrives, we see the density drop as it typically does. And then the speed comes up as the density drops off. Standard coronal hole wind stream effects here. Also, the wind speed is accompanied by a higher temperature or a higher measured temperature. We won't get into measuring temperatures in space. We'll leave that one for Pierre-Marie Robitaille. All right, so check out spaceweather.com. Always interesting articles here, folks. If you haven't checked out spaceweather.com, this is where I initially started watching solar activity in about 2003. So apparently they're predicting G-class geomagnetic storms. According to the geo alert that NOAA sent me, they're only expecting a KP of 4. So that's not even a storm. That's just unsettled conditions. Sunspot number still at 11 due to sunspot 2734. And the 10.7 centimeter radio flux still at 71. So still above forecasts. And that's good. check out spaceweathernews.com. Basically, the X-ray flux still completely flatlined. And here's these spikes in the magnetometer. This is exactly what you expect to see with a crossing of the heliospheric current sheet. We are now associated with the North Pole coronal hole. And the KP is now at 3. We're not expecting this to go over 4. And we see this dip in the electron flux here. This is something we typically see. This is caused by protons coming in from the coronal hole wind stream. Now, you don't see an increase in the proton flux. This is an increase in the proton to electrons ratio. Remember, hydrogen nuclei that have no electron really want an electron. So when they show up at the Van Allen belts, they get their electrons. Actually, we weren't done there. Let's look at charging hazards. Little charging hazards over Central America there. About what you'd expect to see. The F2 layer is looking the same as it's been, although it is a little discharged in the nighttime portion where I am right now. There's your aurora forecasts, and these are looking surprisingly weak, so these might kick up a little bit throughout the day. Let's look at the Space Weather Enthusiast dashboard. And let's just look at the LASCO C3 here. I haven't looked at it for a while. Nothing too exciting going on there, apparently. Here's the Enlil prediction. We try to look at this most days. So yeah, there's that. And you can see we're expecting the velocity to stay up until tomorrow morning, it looks like. So that's the coronal hole wind stream. You can see it up on these images here. Keep in mind, these are models, and they've been wrong before. They'll be wrong again. So let's look at the total electron content. We should see quite low levels here, especially because of that dip due to the coronal hole wind stream. Actually, it looks like we got significant GPS errors over North America once again. They have subsided, though. Okay. So electron content looking pretty normal here. Nothing too interesting to look at. Next, let's look at magnetosphere movies, as we do every day. So first we look at velocity. Shrink that down one size. There we go. We do see some high velocity zones on the equatorial plane around the dusk side of the planet. Surprised we don't see a little higher velocity there from the solar wind portion. Here's the density. And the magnetosphere is pretty compressed here. Although it's not a very extreme coronal hole wind stream, it's just kind of a gentle one. Speeds are not super high, but the density stayed up a bit, so that was interesting. And here's the pressure. There should be a little bit of an angle of attack change due to the crossing of the current sheet, although that happened before this movie's data. And if you're wondering, you can't really request older movies of this yet. I guess they're working on an automated system for that. And let's look at geospace ground magnetic perturbation maps. First at the poles and then at the globe. We try to keep a format going here, folks. And we appreciate your patience. We actually do see some serious pulses there out into the Indian Ocean. Wait till you see how this translates to the global view. I can tell just by looking at the poles that we're going to see some big spikes. So we see big spikes leaking into the Indian Ocean here out of Antarctica, as if the South Pole is headed toward India, eastern India. So the South Pole's kind of going like this. And then we've got two North Poles. There's one over Siberia and there's one over Canada. If you weren't aware, it's true. It's true, to quote Kurt Angle. All right, before we move on to earthquakes, let me look at the chat here since I can't see the chat. Oh, please work. By the way, that track fading out is called Unified Theory 3. As leading proponents of real science, we would love to see a unified theory of physics so that we can do things like benefit mankind with the technology associated. All right, here's our pop-out chat. And thanks for joining us, everybody. Who do we have? Southern California deplorable Henry Lindemann. Welcome. Now, come on. Why wouldn't you be able to ride a bike? Yeah, the slow slip. The slow slip. It's pretty creepy. It's a creepingly creepy slip that's slow. Thanks for sharing to Facebook, and see you later, Mr. Lindemann. What's up, John Moorhead? And hey, Chris Meyer, thanks for tuning in. And look, there's me typing in the chat. All right, back to this. Here's the last 24 hours of earthquakes, and we do have a break in the 6 earthquake magnitude drought. However, it's not a good sign. It's actually a bad sign, and I'll explain why momentarily after I draw in the watch zones, as I do seemingly every day. If you are in these regions, you are experiencing a magnitude 6 and 7 earthquake drought. If you know people that are in these regions, please warn them, because earthquake droughts typically end in anybody, that's right, earthquakes. So now we're going to talk about that 6 in, what is that, Ecuador, I think, Bolivia. We're going to talk about that in a moment, but let's go down the rundown here. So Philippines with a 4.4, 4.5 in Ecuador at depth, 4.6 at Guatemala, right at the northern tip of our South American watch zone. There's one in Japan, right in the watch zone. There's Argentina, 4.8 there, also at depth. Very bad news for South America, folks. Very bad news. Not cool. Banda Aceh. All right, that one's very far west in Indonesia. Excuse me. All right, there's a 4.7 in Papua New Guinea. 4.5 in, there's eastern Indonesia. 4.6 in the Philippines, also in the watch zone. 4.5 in Indonesia. 4.4 in Japan. And there you go, a 6.3 in Bolivia. And that's not a good thing, because I don't know if you noticed, look at the depth. 358 kilometers, one of the deepest ones we've seen there in, I don't know, 2 months maybe? So that's a big quake. I have a feeling a lot of people didn't even feel it because it's in the middle of a bunch of mountains. And because it was at a very deep depth. Let's see what the interactive map shows here. I just want to zoom out a little bit. Give you an idea of where that was located. Right in the middle of a crazy system of rivers. So, in any case, that raises the overall earthquake risk for that area. I mean, earthquakes at that sort of a depth are harbingers for larger quakes at the surface. Kind of a well-known thing. In fact, let's go to windy.com. Let's look at the weather around that area, because low pressure systems that move anomalously are also associated with larger earthquakes at the surface. So let's just zoom out here. That is not the right thing. All right. So we're located right there. Okay. Now let's look at the pressure map. All right. Now that's a good thing. That is not an indication that they're likely to get another quake. I mean, I would still stay on watch because this is serious stuff, but see this anticyclone down here? This is kind of in control of the weather in that area. By the way, anticyclones rotate counterclockwise in the southern hemisphere. I know it gets confusing. Yeah, I don't really see any anomalous lows there. Let's try looking at the wind at the 9,000 meter range. By the way, head to quakewatch.net if you don't know how to forecast earthquakes. Everybody can and should know how to. Little history on me. I've never felt an earthquake, although I've been in several here in eastern Pennsylvania. I was in one that was intense enough where the toilet water in the bathroom was sloshing back and forth when I got there. Sadly, I was walking across the hallway in an office building, and I didn't feel the quake at all. I didn't feel it. I didn't hear it. I was wondering why people were all on alert. Now, let's see what happens here. Let's see if there's any weird lows that move around. We'll let Windy play their forecast. This low out here in the Pacific is a little odd looking. The way it's just sitting still like that. See that? Anyway, I'm not going to sit here looking at the weather all day because it's a pretty slippery slope. Let's look at Oceania just for a second here. The pressure. See if there's any anomalous looking systems, since there almost always are. Move this back. There we go. There's the current time. And we'll let it play through and see if there's any odd looking lows forecasted to be around there. Here's one. Ha. All right. Nothing comes to mind. By the way, windy.com has a fantastic free smartphone app. I highly recommend it. All right. So anyway, let's get back to the list. That was the end of the list. All right. And we'll move on to volcanoes. All right, so today's volcano list, we've got Shivaluch continuing to erupt with a 12,000-foot ash plume. Bezimiany, also in Kamchatka, 10,000-foot plume there. Abiko with a 10,000-foot plume. Sakurajima, still erupting. Looks like an 8,000-footer and a 5,000-footer. Bromo in East Java with a 10,000-foot plume. Tukono, 5,000-foot plume there. Karinci in Sumatra, producing a 14,000-foot plume. Don't fly over that in your homemade helicopter. Popocatépetl, continuous emissions. And Sabancaya with a 24,000-foot plume. That's the star of the day, Sabancaya. By the way, if you enjoy the content and you haven't yet subscribed to the channel, please do so. We've recently hit the 1,000 subscriber mark, and we're not stopping there. We're doing nothing but getting bigger. Always looking for sponsors, affiliates, donors, subscribers, viewers, and those who like to comment. Speaking of those who like to comment, we're going to get a space weather smacking? We sure are. Snap? Well, if you don't have buttons, I hope you have snaps or Velcro or a zipper. You ever heard of Galaxy Zoo at zooniverse.org? One of the largest citizen science projects in the world needs you to help classify galaxies. Here's one. It looks like a massive elliptical. I think there's some features such as a central bulge. That's not an edge on disk. Is there a bar? I don't think there's a bar. Is there a spiral arm pattern? Well, definitely not. We're going to say a large bulge. And we're trying to get our commenters to set us up for that's what she says. So when I start talking about bulges, come on, folks, step up. All right. Is it merging or disturbed? I don't think so. Do I see any rare features besides all these artifacts up here? Or actually, I think that's a background galaxy. That's probably a foreground galaxy. It could be a satellite. I'm not sure, but that one looks like it might be interacting. I'm just going to say something else and move on and encourage you to set up a login here. You may even get published in an astronomy paper. We're going to start adding this as a normal feature here. Stereo A space weather beacon. We've been featuring it on our thumbnails, and this piece of plasma is still hanging out here. Let's see the latest on this thing. Check it out. It looks like it's finally exiting the area that it was. Wow, that's a good one. Let me, since we get a bunch of comments on this one, let's move this back a lot. We'll even raise the resolution here so you can see what this thing does. And I'll blow this up a little bit, since we're only really looking at the Earth side. Oh, and by the way, before we go on here, I just want to explain what this is. We are looking at stereo A here. Let me just go to the Space Weather Enthusiast dashboard to show you a diagram of what we're looking at. This is you. That was a pretty lousy drawing. Let me just, this is you, this is Earth. This is stereo B, which is barely functional after hardware anomalies in 2014. Oh man, what's going on? There's Earth, there's stereo B, there's stereo A. Now yes, the planets rotate this way. It's true. Stereo B is behind the Earth in terms of experiencing solar activity. Most of this stuff is set up heliocentrically. So anyway, that's why they're called what they're called. When you're looking at stereo A, you want to look to the right side. That's the Earth-facing side. Got it? All right, good. So that said, you are out here somewhere, and you're going to be right very close to in line with this equatorial plane here. That's where the interplanetary magnetic field is, and that's where you live. Anyway, check out this piece of plasma on its little journey. You can see it gets pulled out of the current sheet that it's in by this southern current sheet down here. And it's just in limbo, and then all of a sudden it just gets accelerated. Is it a collapse of double layers that's causing that? Well, the true answer is that we don't know, because we don't know why things accelerate the way they do through the solar wind. It could be being pulled out, or it could be current being pushed through the sun. All right, anyway, let's move on here. You don't want to make the video too long. And there's my vanishing pop-out chat again. Thank you, Google. Thank you, Google. You totally know how to write software. Ever hear of debug? Hey, Google, share is not save. Restore normal commands on file menus, Google. It's pretty scary when you agree with Elizabeth Warren that Google should be broken up into all kinds of different companies. All right. Oh, excellent. I answered your question without even realizing I was being asked. Is it psychic powers? Yeah, big earthquake's coming, I think. All right, let's move on here because we don't want this video to be too long. All right, first of all right, we've got some articles here. I want to make sure I'm covering the ones that I looked at during show prep. Yes, I do daily show prep, by the way. All right, first of all, on extremetech.com. Now, this article is all over the place. You don't have to go here, but we will leave links after the stream is complete. Opportunity sends back one stunning panorama. Check it out. Here's the panorama. It's a zoomable thing you can go to. There'll be a link in the article. What a great image. Complete with labels. There's your Logan antenna, and so on. So kind of its final contribution to Martian science. By the way, contact your local congressman or woman and tell them to stop this idiotic geoengineering process of Scope X as they try to determine how many atmospheric aerosols to spray to block enough solar radiation to combat global warming, something that's not real. Speaking of which, let's go back to a video I made yesterday. It's not even 1 minute long, but it features a bunch of stuff that our viewers might find interesting. So let's play it. Here's my logos. And here's a graph of climate change over the last 15,000 years. This is what's supposedly man-made global warming. That. You can't even see it, can you? Exactly. Here's all of recorded human civilization. And here's the state of the Earth's temperature over the last, I don't know, 40,000 years, 30,000 years. Because over the last several million years, the Earth has been in an ice age. When both poles are frozen, that's the definition of an ice age. Let's move on to the next slide here. Here's the Earth's temperature over the last 542 million years. Let it sink in. Let it sink in. Keep in mind, this side of the graph is zoomed in. You see these high temperature regions? That's what allows you to be alive. If we were down here, if we even went to here, we would lose millions, probably billions of people due to global crop losses, something we're already seeing right now. Let's go to the next slide. Total snow mass for the Northern Hemisphere, excluding mountains, as of, looks like mid-March, early March, let's say the first week of March. How do glaciers form? Well, glaciers form when snow falls and then doesn't melt, and then more snow falls and it compacts into an ice sheet. That's how glaciers form. We're like 400 gigatons above the 1982 to 2012 Northern Hemisphere snowfall average. Do you remember last year's late spring? Do you remember this winter's early winter? Are you ready for this year's late spring? Have you planted stuff inside early to get a head start on climate change, which is causing crop losses all over the world, and things like 12-inch deep hailstorms in Paris, flooding in the Sahara Desert, etc.? These are not features of a hotter planet. Whoops. All right, let's go back to that one. See that blank look? It's not going to be as blank as the look on your face after you hear this revelation.
Because now we are approaching infinite resources.
Good news, dudes. Now we are, quote, approaching infinite resources. A brilliant, brilliant congresswoman told me through the grapevine. So yeah, we're approaching infinite resources, folks. Isn't that great news? Isn't that wonderful news? Infinite resources. Apparently, she doesn't know what the term infinite or resources means. But besides that, we have no beef with Einstein-level Congresswoman Alexandria Ocasio-Cortez. Well played. Well played. We're now approaching infinite resources. I mean, I'm just speechless. All right, we got more articles here. Just give us a minute. All right, Cosmos Magazine. Here we got one that made us laugh. And it sounds legit to me. Acting out for actors. Getting into character means shutting off parts of the brain. Have you shut off parts of your brain, Mr. De Niro? Do you believe in man-made global warming, Mr. De Niro? All right, enough of that nonsense. Let's head to Science Alert. A bunch of articles on here. I'm trying not to miss any because there are a lot. Oh, and this one's super cool too. All right, so this is great news, by the way. Scientists clear Alzheimer's plaque from mice using only light and sound. I recommend you read that, as Alzheimer's is a growing problem. Here's what Facebook said about yesterday's huge outage. We're not going to cover it. Here's what I say. Oh, Mark. Your surveillance state must have been disrupted, Mark. Sorry to hear that, Mark. Apparently, a magnetar has come back to life. It's showing some high frequency transients, basically. And now I was wondering what was going on with this, how long we've been studying it and so on. So I decided to actually go have a look. I actually typed it in. I didn't really type it in, I copy pasted it. Anyway, so I went here to the transients. I think that's the right page. There we go. And I searched for that, and sure enough, it is there. All right. Please bear with me. I don't know where the search feature is. There we go. Okay, will you show it to me? Come on, Brave browser. What's the point of that? All right, well, it showed me, all right. Anyway, you can track this. You can actually watch this thing's transients. Now, I don't see any big X-ray spikes. Man, I can't understand why I can't find that. That's bizarre. Let's try that again. Find. It found it. I guess I got to scroll down through hundreds and hundreds of results. Come on, Brave browser. You got to fix this feature. You know what it's like scrolling through a web page like this, Brave? Hook us up, Brave. Let's go back to the chat here. Oh, geez. Google. Oh, man. All right. No more pop-out chat. All right. Let's see. Yeah, cold kills people. Hot doesn't kill people. We could use a couple extra degrees of temperature as we could grow a lot more crops on this planet if it was a little warmer. If it was a little colder, you might find yourself dead. Like, she auditioned to like play the part like of, I mean, a US like congresswoman. And there are like so many. I heard there are 13 like clowns like in the race, all right? So, I mean, like there are totally like a lot of people who are so skilled. I mean, Beto O'Rourke is just such a candidate. He's got so much soul. Anyway, Magnetar has come back to life. It's interesting. Go read about it. Moving on to more things, because there are quite a few more things yet. I'm going to go to phys.org, as there are some articles there to bloviate about as well. And I don't remember which ones. Let's see. First, I would direct you to the Earth tab. Tectonics in the tropics trigger ice ages. That's interesting. Self-forming waterfalls reported. That's a stupid article. I read it, and I lost an IQ point. Buying and selling cattle can link individual farms. Okay, here we go. Look at that. Catastrophe cycle covered on a mainstream news source. Major cosmic impact event 12,800 years ago. Yeah. It's a solar nova. And this article is going to suggest that it was caused by a comet that broke, a comet that broke apart. Impact hypothesis. And this has to do with mechanistic astronomy, folks. The only tool in the toolbox of astronomy used to be impactors. So anytime you see a disaster, it has to be some kind of a comet or an asteroid. Couldn't be the sun when they included a black mat layer. Yeah, so anyway, that's another article for you. In the Earth section. Now, I want to go back to this tectonics at the poles, because even this article, they figured out a way to put some stuff about CO2 in here. The heat and humidity of the tropics likely triggered a chemical reaction between rocks and the atmosphere. Specifically, the rocks, calcium and magnesium, reacted with atmospheric carbon dioxide, pulling the gas out of the atmosphere and permanently sequestering it in the form of carbonates such as limestone. Well, okay, at least they're not telling us that it's our fault. There's more, and this is a good one. Whether it's correct or not, I have no idea, but researchers unravel mysteries of Earth's inner core. A lot of reading for our viewers today. Everybody worried about things like pole flips. This is one of the first attempts at tomography of the Earth's inner core. Now, is that unbelievable? Is there a sea of liquid iron and nickel down there? I don't think so. It's made of condensed matter. Of course, liquid is condensed matter, but that's not what we're talking about here. Anyway, they're using a combination of, well, you know, tomography, the same way you do it in medicine there. They're using x-rays and ultrasounds and interpolating all that data together. The Earth is a giant resistor, folks, and there's current flowing through it and you right now. All right, anyway, we'll leave links to all the articles here. We're trying to close out. Got a couple more segments. Again, end ScopeX. If you see a petition, put it in our comments. We will sign it immediately. Here's your planet locations at theplanetstoday.com. And we'll advance it 1 week so you see what's happening then as Mercury moves out of conjunction. There's the full moon coming into play. There's a star map. I can't get this to display the things that I can display on the mobile version for some reason. This is a great star map. If you head to in-the-sky.org, just put in your location, and you'll be able to actually automate this so you can see, you know, where given stars will be at a given time. Super great planetarium. Allows you to identify the things in the sky you'd like to identify. Now, what I always do is I always face to the south, and I turn on the ecliptic. And I don't know why it doesn't work. There's some way to do it. I'll figure it out sometime. Also, I would recommend that you visit theveloshop.net, official cycling team of smAsho. Yes, I'm what you would call an unable to retire cyclist. And this is the local bike shop, so support your local bike shop. If you don't have a local bike shop, head to VeloShop. There's the owner, by the way, Becky Quinn. Head to the site and, you know, work out a deal. Most major brands they cover, and I'm about to get a new felt from them. Actually, I need a new road bike, so I'm going to be looking at something like, oh, I'm not really sure. I like BMC also. Cervelos are nice. Although Cervelos don't fit my body very well because the top tube is too long for my short torso. BMCs have some of the most advanced carbon. So they carry Focus, they carry BMC, most of the major brands that you would see in the Tour de France. Yeah, veloshop.net. They got great team clothes there too. Anyway, we got to close this thing out. Let's turn on some music. And we're going to play some images of the sun here. Let's show you just today at 94 angstroms. Maybe that'll be the new standard. Get the latest images for you. And I'll bring out the chat. All right, let's see here. Thank you, Kyber. Thanks, Kyber. We appreciate the recognition. Please share on your social media. Well, Mr. Moorhead, you realize that the Earth doesn't need to have a liquid metal core. All you need is a magnet moving through a magnetic field to create the Earth's magnetosphere. You don't need all that mechanistic stuff inside the planet. And I don't believe it's there. Just like the sun is not a ball of plasma, the Earth is not a ball of molten rock. Once you get below that molten layer, you probably have liquid metallic hydrogen, just like the sun. Hey, troll it up, dude. Troll it up. All right. Here's your view at 94 angstroms. We are going to get out of here ASAP. Because I got to be headed out in the field to do applied science in about an hour. So there's your view at 94 angstroms. Thanks for tuning in. If you want to stare at the sun today, I have a recommendation. Watch this area. As there's some activity going on there, it could suddenly spring into life. If we see a sunspot form there, that's very low latitude there, very far from the equator. And sunspots far from the equator are not associated with solar minimum. By the way, we did catch another sprite here, thanks to the 94 angstroms. Let's see if I can catch it. I went past it. It's not as obvious as some of the previous ones that we've seen. I pass it again. There it is, right there in the center of the disk. Nothing too exciting though. Anyway, we greatly appreciate you tuning in, and have a delightful Friday. Don't do anything I wouldn't do. I guess that doesn't narrow it down. Remember, when you're staring at the sun, don't drink. And if you drink, stare at the sun through the proper filters or telescopes or SDO instruments. And don't drive.